So, so the last day I was here, the last thing we did was to approximate square roots, where we learned to press the button on our calculator to get the square root of 39, and where we learned to press the calculator button to get the fifth root of 749 by going up arrow. We really should be on time with 10 minutes in between. We really should. All right, so we get these up arrows, we get these up arrows. That was called approximating. Now yesterday, during my absence, we went to simplify. Let me make this very clear because I want to get caught up and I don't want anyone behind. Simplify does not mean to press the calculator button. It means to get as small as possible numbers, that's a weird, under the sign. When directions say to simplify, you do not, when it says simplify, you do not press the button and just press it. If you have a fancy calculator that does that for you, you are not allowed to use that function on your test. So the first one that I'm going to look at is h. I'm just going to look at the square root of 12 part. I'm just going to look at the number part first of all, and then I'll put them together. The number part I'm going to look at. All right. The list, the last day I was here, of perfect squares was square root of 4, square root of 9, 16, 25, 36, 49. It goes on and on. We may need some of the higher ones. What you try to do is see if any of these perfect squares go into our number. You use a calculator and go 12 divided by 4, or if your head can do 12 divided by 4, you do that. Either way, does 4 go into 12? It sure does. Is 4 the biggest of these numbers? It sure is. So what you do is the first step, everybody keeps their hats on, and you write 4 times 3. We're trying to use one of these. And besides one of these, we're going to try to use the biggest. So 4 times 3 is 12. Now I say, please take your hat off. And it says, yes, sir, I would. Take your hat off. No. Wow, jerk. All right. So this becomes 2 square root of 3. That's how the number part works. I'm going to look at the number part for letter O in just a moment. I'm going to wait for 5-6 seconds because I see a handful of you writing this down as notes, which is awesome. All right, I'm just going to look at the number part of problem O, the square root of 45. Just the number part. So either with a calculator or with your head, see if 4 goes into 45 evenly. Yup or nope. Either your head or your calculator says yup or nope. Nope, must be nope. Either your head or your calculator does 9 go into 45. It does. Remember that. Let's try to get a bigger one. Does 16 go into 45? Nope. And 25, once we get over halfway, no way it's going to work. So people said 9 and 5. The first step is everybody keeps their hat on. The first step is everyone keeps their hat on. All right? And I go to Caden. Caden, please take your hat off. And he goes, I'd be glad to. And square root of 9 of 3. And then I say to Kirby, who's sitting behind Will there, says, Kirby's got a hat on. You say, take your hat on. Kirby says, I won't. And so it stays like that. So that's how the number part of it works. I'd like to look at the number part on letter A near the bottom. I'd like to look at the number part on A near the bottom, and that number part is the square root of 54. Either with your brain or your calculator, see, does 4 go into 54 evenly? It does. It does not. It does not. It does not. Does 9 go into 54 evenly? It does. 6 times. Keep that in mind. Let's try a bigger one. Does 54 go into it? Or 16 into 54? Nope. And 25, once we get about halfway, they're not going to work. So we have 9 and 6. We write them with their hats to start with. Please take your hat off. Square root of 9 says, yes, I will. Square root of 6 says, no, I won't. So that's how the number part works. That's how the number part works. Now the variable part works differently because of those exponent rules. And because of the exponent rules, x times x gives us x squared. So the square root of x squared is x. X to the second times x to the second is x to the fourth, which means the square root of x to the fourth is x squared. X to the third is x to the sixth. And you're going to see a pattern, and this pattern is the following. With exponents, even exponents are perfect squares. So is x to the 24th a perfect square? Is x to the 100th a perfect square? Is x to the 7th a perfect square? No. All right. So on number t, and I believe, in fact, t is a letter. So on letter t, it says 9x squared. We're going to do this in two different parts, The number part. Say, is the square root of 9 just an easy one? Just immediately becomes a 3. And does the x squared become something without a hat on it? Becomes an x. There we go. So that's how number 1 works. All right, as we get to, let me try letter E. And letter E says the following. That negative is just going to hang around. It's just going to hang around. All right, I'm going to do this in separate parts. The number part. 4 goes into it 7 times. Is x to the 4th going to become something without a top on it? It's going to become a regular x to the 2nd. All right, how we like to write it is the number first with no hat on, any letters with no hat on, and then the people with the hat have to sit at the end. Okay. Letter E on the bottom, and now I'm noticing there are a number of letter E's on the bottom. But the first letter E says the square root of a to the 3rd. All right, you will notice on this list there are no square roots of a to the 3rd or x to the 3rd. There's none of them. So what we do is we break it into one less. So we make it into a to 2 and a to the 1. A to the 2 and a to the 1. I hope that student is not on his phone who pretends like he's on his phone so I can clearly see a phone where his attention is. I hope that's not the case. I hope I'm wrong. All right. Now, does the square root of a to the 2nd take its hat off? It does. It becomes just a. Will that take its hat off? It will not. That's your answer. Now, I want to bring back a little learning from, I think this is Monday. A little learning from Monday. Could this one right here, this one be written as a to the 2 over 2? Remember that from fraction day? A to the 2 over 2. What is a to the 2 over 2? 1. A to the 1. Cool. So let me look on the bottom and let me look at problem number, H. And H, I believe, is a letter. The square root of 15. A to the 8th, B to the 3rd. And I'm going to break these into 3 little parts. Square root of 15. By the way, do any of the numbers that I erased, were any of those numbers, does go into 15, does 4 go into 15, does 9 go into 15? Nope, square root of 15 is going to keep its hat on the whole problem. I'm going to put the square root of a to the 8th In just a minute, that's going to become a to the fourth with no hat on it. All right, if you've got an odd number, you make it one less. So you make it b to the 2 and b to the 1. Okay. People with their hat on are going to go at the end. You're going at the end. Does the square root of a to the 8th become a nice thing without a square root sign at x and a to the? It'll go up front. Will b to the 2nd with a square root become a b? And now the people at the end that kept their hats on will keep their hats on. Does anybody understand worse than they did yesterday? You understand worse than you did? Now it's worse than it was. Wow. I did not do my job well. Okay, I will work with you individually. Are there any that are the same as when they walked in class? And are there some that are better? Okay, I am shocked that there's somebody who's gotten worse because I taught them. All right, well, that's going to make me cry. All